Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in statistics. Of course, that's a branch of mathematics that it deals with a collection and an analyzing of large quantities of numerical data. But our main bias for today is going to be measures of central tendency, and we're going to look at these three concepts of this is typical values for probability distribution. That is for the concept of the median, and mode. So without further ado, thank you and welcome. So as I've said, we're going to look at the concept in statistics. And as I've said, this concept is a measures of central tendency. And under measures of central tendency, we're going to look at the concept of mean. Of course, we have other typical values for probability distribution. That's apart from the mean, we have the median, mode, which of course are part of the concept of central tendency. But we're specifically going to look at the mean as a measure of central tendency in our discussion. So in this case, before we go to our concept of this mean, statistics as a branch of mathematics, of course, as I've said, is a science or a mathematical concept or a branch of mathematics that deals with the collection, analyzing, and of course trying to interpret numerical data, which is large quantities. So in this case, of course, I've talked about collection and then analyzing, of course interpreting numerical data that appears in large quantities. This numerical data can be either maybe grouped or ungrouped set of data. So in this case, this is the procedure that is used especially for the purpose of inferring proportions from this whole set of data in order for one to come up with a conclusive result from that particular set of data. Now, statistics as a branch of mathematics has a wide range of applications, all the roles it plays in our day-to-day lives. So therefore, giving the need for it to be looked into. So the first one is that statistics assist us to make informed decisions. Especially when it comes to the concept of business or commerce. A particular set of data or maybe a trend in business can assist us in making a decision, especially which pertains to finance and other areas in business. And secondly, it's going to assist us in trying to mitigate or maybe understand risks. And therefore engage in emergency preparedness. Either to mitigate or try to handle the risks which come by. So in this case, of course, in statistics, if we take information from the natural occurrences or phenomena like the weather, this one assists us in following trends. For example, in the weather patterns. So this one will assist us to try and figure out on how we can be able to utilize this information for the purposes of our activities like agriculture, etc. And therefore, we can also have another one, in that is statistics assist us to conduct research and trying to collect and compare different areas in order to interpret maybe a specific phenomenon. Now in this case, of course, it's going to assist us also to make predictions about the future and other areas. So these are some of the specific roles that we're going to see that statistics as a branch of mathematics is going to come handy and assist us in trying to handle challenges and other areas appears that we come across in our day-to-day lives. So that one said and done, we've introduced another concept here. This is the concept of central tendency. Central tendency. In this case, from this word central, this is a concept of typical values for probability distribution. These are typical values of probability distribution. Of course, in this set of data that we have talked about, and this of course includes the mean, the mode, and the median that we have talked about, or as well can be a measure of or a statistical measurement that identifies a single value as a representative of the entire distribution. Of course, this one assists us, the measure of central value assists us understand the concept of grouped and ungrouped data that I've talked about. Therefore, it is significant in trying to interpret a large number of data. So for that, so this ungrouped. So it assists us understand a large quantity of groups, grouped or ungrouped data in that case. So for the concept of the mean that we have talked about, as we have said, the mean refers to of course, the average value or the common value that appears in a set of grouped or ungrouped data. And therefore, we are going to see on how this particular mean, concept of the mean, can be derived from a set of ungrouped or grouped data. So therefore, as I've said, basically we can find this one as an average. It's an average for the most common value in a set of data which of course is referred to as the mean. Or as I've said, as it falls under the three categories that we have mentioned of measures of central tendency, the mean, median, and mode, we can define the mean as a measure of central tendency of probability distribution alongside the mean, median, and mode. Sometimes in some literature we can find that this concept of the mean is being referred to as an expected value. So therefore, in case we come across this particular expression that is implying an expected value, then we are going to conclude that that one refers to the mean. Now, for us to try and understand this concept, I'm going to use specific examples to try and illustrate what the concept of the mean means. Therefore, I'm going to give us a set of data that we are going to use for that purpose of trying to figure out what the concept of the mean refers to. So in this case, let me just give a set of data on the board so that we can be able to use it in order to derive the mean. So the first set of data, 7, 11, 11, this is 8, 12, 7, and then we have 6, 6. This is a set of data that has been arbitrarily collected from somewhere, representing a particular information. So in this case, we're going to see that there are different terms that are going to be introduced. And in this case, we're going to denote the mean using that X bar, and then the number of this set of values 1, 2, 3, 4, 5, 6, 7, 8. The number in which they appear irrespective of whether they are repetitive or just single ones, and it is what is going to be referred to as n. So therefore, and we know from sciences and other aspects of mathematics, there's a symbol that we use, this is a symbol for summation. So therefore, we are going to have an expression for representing the mean. This is the mean, and this is the number of values. And this summation, this is a total of all values that are being represented in that set of data. So therefore, I'm going to give the expression that is going to refer to the mean. So therefore the mean is given as, this is a fraction of that range of values, or maybe a division of that range of values, which I've said that it's going to be n. So for this 1, 2, 3, 4, 5, 6, 7, 8. Therefore our n for us is going to represent 8. And we are going to have a summation of those values from the first I to the n number, which is of course I've given our n as 8. And this is the summation of all these values. So these values are going to be represented by x. That of course is appearing there. So this represents the values. And this is summation for all the values. This sign represents the summation of the total values. So therefore we can say that it is xi to n. That is the expression that we have given there for the mean. So I'm going to find the mean for this. So the mean x is given as, x bar is given as 1 over 8 into 7 plus 11 plus 11 plus 8 plus 12 plus 7 plus 6 plus 6. So this is going to give us 68 divided by 8, which is going to give us 8.5. So the calculation for this particular expression from the range of values that we have been given is going to give us 8.8, and that one basically represents what we call our mean. So from a range of ungrouped data, we can be able to find our mean using this particular criteria. So what of a set of organized data that I've mentioned before, that is can be of either organized or grouped or ungrouped data. So for a set of organized data, we are going to see that there's a different way in which we're going to find the mean. And I'm going to give an example of that using this sample question 1. Suppose we have a set of organized data, and remember we're going to use this one to refer to frequency. So therefore, let's look at this set of values that we have here. This is for the f representing the value, f for frequency. This is x for the value, f for frequency, and fx as a product of the value and the frequency. So we have this set of data that I'm going to write here. This is 1, 2, 3, 4, 5, 6. And then for this frequency, 1 appears 8 times, so we have 8. That refers to the frequency, the number in which a value is repeating. It's therefore appearing 7, 12, 3, 1. So this one coincides with this horizontal. So the product between this one and this one is going to give us 8, 28. And then we have 21, 48 for this and this. The product between those two, 15, and then 6. So therefore, we've mentioned that we're going to find our mean using the summation of the frequency, the summation of the product of frequency times the values, and then divided by the frequency, so the total frequency. So that one is given as that. So therefore, if we try to find the summation of this particular column, the total here is going to give us, of course, 126 divided by 45. So therefore, this is what is going to give us, and the value for that is going to be, of course, 2.8. So therefore 2.8 is going to be our mean from this set of values that we have organized in this tabular form. So I'm going to give a range for data that this is an organized kind of data, but I'm going to give another example for grouped data, whereby of course we're supposed to use this range of x. So we are going to find out that instead of this data x appearing as 1, it's maybe a range of data or a class of data that is ranging from 1 to 5, maybe 6 to 10, etc. So we're going to introduce a new concept known as a midpoint that we're going to use in order to try and find out the mean from such a kind of range of data. So for that case, I'm going to use a table for illustration, and then it's going to assist us in finding our mean. Now, as I've said, if the data is grouped, of course, we are going to use a different concept, that is the midpoint. And that is going to assist us find the mean for, sorry for that. We're going to use this midpoint, and that is going to assist us to find the mean for such a kind of course, numerical values or the data which has been grouped. So therefore, this is going to, or is going to, to assist us in finding the mean. And this, the midpoint, is going to assist us, of course, in trying to find a representative data from the raw scores. So therefore, as we said, our mean is given as the summation of Fix and then the summation of frequency. That is from, of course, I to n, I to n, I to n. But in this case, if we have a class which is represented as that, then we're going to find the mean, of course, using these two different sets of data. That is the summation for the x, which is the midpoint, and then the summation of the frequency fx. So how do we find the midpoint? Now, for instance, for the first set or a class of data that's between 1 to 10, the midpoint is going to be this 10. This is of course just for a range of numbers, especially for the first class of data that we have. We can just arbitrarily just list the values that are contained in there. So this is 1, 2, 3, 4, 5, 6, 7. Okay, space is small, so I use this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at this particular point, we have 5 values at this point and another one. So for this case, the values that is going to be a midpoint for us is 5.5. And that now, with these respective values, those are the values that I've computed in this particular column. So in this case, we are going to, as it appears from this, we're going to use this one to represent, as I've said, the raw scores for that column. Therefore, the summation for the first one here is going to be 1980, and then the summation for the second one, that is the summation for frequency. This is the F column. Of course, it's going to be summation for frequency is going to be 40. So bear in mind that this is the product between this one, and this one is a new concept that we have said we use it to represent the data for that particular class that we have called the midpoint. Therefore, our mean for this is going to be 1980 divided by 40, which is going to give us 49.5. I hope I've done my calculations right. So this is 2, this is 999. Okay, that's correct. So our midpoint, I mean our mean for that is going to be 49.5 for that set of data which has been given as a class. So in this case, this is the approach that we're going to use in treatment of this specific range of data. That is for, of course, for group data. For ungroup data, we are going to use the concept that we have already discussed. So this is how we are going to use these two particular concepts in finding this measure of central tendency that we call the mean. And maybe in other cases whereby we may find that there are new concepts which have been introduced, we'll of course refer to this one and try to compare it to what we have come up. So in that case, that is it for today. So thank you guys. Subscribe to our channel for more, and so that we can be able to share information and discuss on other areas in sciences and mathematics. So for that, bye. God bless you.